Hello, we are Group 5 of the CHEG Senior Lab. Our group members are Kyle Kennelly, Thomas Clifford, and Ronald LaMonica, and today we're going to be discussing the details of the caffeine extraction lab. The objective of this lab is to examine the impact of different variables on the rate and amount of caffeine extraction. It is possible to test different variables and determine which of the tested variables has the greatest impact on the rate and amount of caffeine extraction. The possible variables include, but are not limited to, temperature, flow rate, mass of the coffee, type of the coffee, size of the coffee grounds, packing, residence time, and exposure to extraction solvents. Our group selected temperature as the first variable to test, with 3 different temperatures being used: 50 degrees Celsius, 70 degrees Celsius, and 90 degrees Celsius. For the second variable, our group decided to do coffee type, using cheap coffee, medium roast coffee, and finally espresso. Before we can begin testing our 2 different variables, we need to create a calibration curve that will relate the spectrophotometer readings to real-world concentrations of caffeine. To do this, we need to take dichloromethane out of its large volume container and then further measure it to a set volume and then combine it with a known mass of caffeine, allowing us to calculate out the final concentration and keep further diluting it to get multiple points along a calibration curve. Now, before discussing the actual calibration curve we came to, we're going to see a quick demonstration of how this is done. As you can now see on the screen, the calibration curve that our group used is there, and it shows an extremely linear relationship between concentration of caffeine and the readings given by the spectrophotometer, making it very easy to convert between the two at the end of the lab. Now that we have our calibration curve, we're ready to begin setting up for our trials so we can start testing the 2 variables selected. Now, to start, you're going to want to grind up your coffee grounds, and then you're going to need to have picked a packing method for your column. Our group selected the wet packing method, but a very similar one is the dry packing method. Now, in the wet packing method, we're going to be inserting a cotton ball into the base of the column and pushing it all the way to the bottom, and then inserting a set mass of sand over that. Our group used 5 grams. After that, you're going to insert the solvent, so in this case, it's going to be water. And then after that, you're going to mix the coffee grounds that you've just ground up with some water into a slurry and then pour that into the column and allow the coffee grounds to settle, tapping it a little bit to make sure that there's no air bubbles or any space between the coffee grounds. Once you have that, you're going to turn the knob at the bottom, allowing the solvent to flow out until the solvent is at the same level as the coffee grounds at the top. Now, it can be a little bit confusing to just try and listen to, so there's a diagram on the screen right now that depicts how this can be done, and once you're at the very end, you're actually all set to go on starting your first trial. For the solid liquid extraction portion of this lab, you're going to start off with the packed column that we just talked about, and you are going to set the flow rate of your system so that the column is at steady state. You're then going to want to insert a graduated cylinder below the column, which will catch all of the water that has the extracted caffeine in it and allow it to fill up to 15 milliliters before swapping it out for another graduated cylinder and allowing that one to fill up again too for however many trials you'd like to do. In our case, we did 3. Now that we've completed the solid liquid extraction portion of the lab, we need to move on to the liquid extraction portion. To do this, we're going to take the 15 milliliter sample of water with caffeine in it and put it into a separatory funnel. Along with this, we're going to put 15 milliliters of dichloromethane into that separatory funnel and invert it 3 or 4 times, which will allow the caffeine to move from the water to the dichloromethane, and then we'll allow it to settle with the water coming on top and the dichloromethane on the bottom due to the difference in density, making it very simple to turn the knob and allow the dichloromethane to flow out the bottom. And once that is all out, you will turn the knob, allowing the rest of the water to remain in, repeating this step 3 times total to make sure all of the caffeine is extracted out of the water and is in the dichloromethane. Once all of the caffeine is in the dichloromethane, we can take that, put it into the spectrophotometer, and get an appropriate reading that will be put into our calibration curve to get the final concentration. One thing to note is that many times the dichloromethane with caffeine in it needs to be heavily diluted before it can actually get an appropriate reading, due to the max reading on the spectrophotometer being 3 and it being above that. Now that we've discussed how to complete the trials and actually get your data, we can go over our group's results, which can be seen on the screen right now in a time versus concentration graph. Now, this graph includes both variables tested, being the cheap coffee run at 90, 70, and 50 degrees Celsius, along with the 3 different types of coffee that were ran, being cheap coffee, medium roast, and espresso. So the first variable that we can go over is the type of coffee, as that was the most impactful. As you can see, all 3 trials of espresso fall around 0.27 to 0.26 for the concentration. The medium roast falls around 0.21 for all 3. And then the cheap coffee, regardless of the temperature, falls around 0.14 to 0.15. Now, this means that the type of coffee had a very big difference in the amount of caffeine extracted across all 3 trials, meaning the espresso most likely has the highest concentration of caffeine in it, and the cheap coffee has the lowest by far. Unfortunately, our second variable tested, which was sort of already mentioned, being temperature, was completely inconclusive, as the increase in temperature did not yield an increase in caffeine extraction or a higher extraction at the beginning trial and lower at the later trials. It was just completely inconclusive, as all the trials overlapped and there was no correlation between anything.